Okay, for this second video, I'm going to go through one of each section, one of each kind on this middle section. And you'll notice that there's 6 graphs here with all these different types of key features. So one of the things that we focused on is the different forms and then pulling key features from all those different forms. So just be comfortable with that in any of the forms. So I'm going to walk through this first one. Again, the key for all of these are posted in Canvas. I'm just going to walk through a couple to give you a good idea of the kind of how to think through each problem. So the first one that we're looking at, we're given this function y is equal to 2x squared minus 8x plus 6, and we're asked to identify its form. Then once we find the form, we're going to find the vertex and each of these key features. The only one we're not going to find, and I crossed it out on all the others, is the positive and negative for our class this year, so don't worry about those ones. Okay, so looking at this one, we talked about there are those 3 forms. In the last video, I kind of wrote them out. We have this one right here that has the h and the k. That's our vertex form. We also have the ax squared plus bx plus c, which is standard form. So we're looking at that one. Again, this one's vertex form. And then lastly, we have the factored form, or it's often called intercept form because those solutions give us the x-intercepts. So this one's intercept or factored form. And to find the vertex on each of these, remember that vertex form was pretty easy. We just had to take the opposite of whatever the h value was and then use that k value that gave us the vertex. Standard form took a little bit more work. We had to take the opposite or the negative of the b value and then divide that by 2 times the a value. That gave us the x piece of the vertex, and then we had to plug the x piece in to the original equation to find the y value. So we could find the vertex doing it that way. And then intercept form, again, we covered a little bit. You can go ahead and plug it in the calculator. You can find those x-intercepts. The vertex always lies halfway between those intercepts. And then we can plug it in to find the y value, so I'll kind of show you that. So this first one, if we look at this is definitely in standard form. And if we move forward with standard form, then if I want to find the vertex, I'm going to write this first. This is in standard form. The vertex would be found by using what I said above with the negative b over 2a. So here your a value is 2 and your b value is negative 8. So if I want to find the vertex, I'm going to take negative 8, but it's like a negative 8, so positive 8 divided by 2 times the a value, and my a value is 2 in this case. And that would give me like the x value of the vertex. So I'm going to write this kind of weird so that you can tell that's what I'm finding in the vertex. 2 times 2 is 4, so 8 divided by 4 gives me a 2 there. Now once I know the x value, anytime I want to find its partner y value, I just put it into the original equation. So my original equation was 2 times x squared minus 8 times x plus 6. So if I go ahead and I just put that x value that I found inside of here, and you can plug that whole thing in your calculator or work that out by hand, and you should end up with a negative 2. So we get negative 2 right here as the vertex. Now, if we look out front of our graph, remember the positive 2 means that this graph, this U shape, is opening up, right? It's smiling. So it has a low point, and that vertex would be the lowest point on the graph, so we would call it a minimum, okay? The axis of symmetry, once we have the vertex, we know that it always goes through the x value of the vertex, so we've been practicing that quite a bit. Once we know the axis of symmetry, so remember I'm going to draw another little picture right here. That axis of symmetry is at 2, well, it's messy. And it looks like we're decreasing on this side and then increasing on this side. So down here, I'm going to decrease on the left of 2, and I'm going to increase on the right of 2. Or if you like saying 2 to infinity, that also means the right side. Or negative infinity to 2, that means the left side. So you can write it in either way. Our domain for all of these is negative infinity to infinity. So we're good with that. And then our range, again, goes from our y value, the lowest y value, and this one's going up forever. So our y value there of our vertex is at negative 2, and then it's going to go up forever there. X-intercepts. So x-intercepts, again, are easiest to find from intercept form, and we know how to factor it to put it in intercept form. So if we take our original equation, y equals 2x squared minus 8x plus 6, and we factor out the 2, we end up with x squared minus 4x plus 3. And if we keep factoring that, right, we split up our x as x and x. We know that they're going to be the same sign, and they're both going to be negative, so they have to multiply to 3 and add to 4, so that would be a negative 3 and a negative 1. So your solutions here, right, are 3, so 3, 0 would be an x-intercept, and then the other one coming from that other piece is 1, 0, so that would be an x-intercept. So when I start to plot my graph, I can use all these points to kind of help me. And maybe I'll start with the vertex, which was at 2, negative 2. That will be the lowest point on the graph. I know that it's going to cross at 3, 0. And it looks like 1, 0. And then the only part I didn't find was the y-intercept. Now remember, y-intercepts occur when x is 0. So if you were to put 0 into your equation for x, 0 times 2 and squaring it, that goes to 0, that goes to 0. So really, when y is 0, when x is 0, the y value is 6. So on my graph, I could also put a point at the 6 up here. Notice that's going to create a nice little U shape to create your parabola there. So you need enough points there. Oh, I missed the vertex to represent that graph. So that's standard form. Let's jump down, look at one in vertex form. So we've got number 10 right here. This one's kind of the quickest to do as far as finding the key features because our vertex is already given to us here with h and k. So this one is definitely vertex form. And the vertex, again, we do the opposite of the h, so positive 1, and then we have positive 3. The axis of symmetry goes through that x value of the vertex. Max or min, we look to see out front. Notice it's a negative 2 leading the equation. So this one's upside down, so this one's going to have a high point. So this one would have a maximum there. And again, if this is like our axis of symmetry at 1, it looks like our graph is increasing first and then decreasing on the right. So we're going to increase on the left and then decrease on the right of our axis of symmetry, which is at 1. Again, if you want to write 1 to infinity, you can do it that way too. You don't need both, just whichever one you're more comfortable with. Both of them will be on your multiple choice questions on your test, and I'll accept both written in for the short answer. Our domain is always negative infinity to infinity. And then again, our range, if this one's opening down, comes from negative infinity and will stop at the y value of the vertex. So we're going to choose to use that 3 right there. Okay, oops, it needs a bracket. Awesome. The y-intercept here, again, y-intercepts occur when x is 0, so just like I wrote on the last part. So again, if we were to come up to the equation, and I'll write it out right here, but if I was to go and put a 0 in right here for the x, then I end up with negative 1 squared, which is just 1, times the 2. And again, you can just plug that whole thing into your calculator if you want, but it should come out as 1. So my y-intercept here is 0, 1, and I'll box that so you can tell. So when I'm graphing this, my vertex is at 1, 3, and it looks like my y-intercept is at 0, 1. So it's going to cross again over there. We make it symmetric. And again, we're just going to do the best we can to kind of draw our graph headed down this direction. You just need enough points to give it a correct shape there. And we could always plug this into the calculator and just kind of check where it's at and make those super accurate in drawing our graph as well. All right, let's jump to the last one. The last one is intercept form, so 12 and 13. Again, this is factored form, so if I'm looking at this, I'm going to write out intercept form here as far as the form goes. So this is intercept form. I can tell, again, by looking out front, this is 1/4, so this guy's opening up. So we know that this is going to have a minimum there at the bottom. The thing that the intercept form gives us is those x-intercepts. So if we look up here at our function, you'll notice if I look at this piece right here and this piece right here that's been factored, if we were solving this, we would end up with x equals -5 and x equals +3 to make that a 0. So our x-intercepts here are 3, 0, and -5, 0. And again, if I want to find a y-intercept, they occur when x is 0, just like we did on the last one. So we would just take our equation and we would put a 0 in everywhere there's an x. And if I simplify that, I get 1/4 times -3 times 5. And again, you can put that whole thing in your calculator. So this is really 1/4 times, and we have negative 15 there. So if I'm going to write this part out, we're just going to say that if I were to plug that in there, 1/4 of that would actually be at 0, -3.75. So that's our y-intercept. And then again, we need our vertex to do the other part. So there's two ways you can find the vertex. One way that we kind of did it in class and the students were figuring out is that if I plot these x-intercepts, so one of them's at 3, the other one's at -5, your axis of symmetry or your vertex has to be halfway in between those. So however many units over here and however many units over here, it has to be right in between there. So 1, 2, 3, 4, right? 1, 2, 3, 4. It looks like it would be right here. So your vertex is there at -1. That axis of symmetry has to be right between them. So the axis of symmetry is at -1. We know that -1 is the x value of our vertex. If I want to find the y value, again, you just plug in an x. So if I ever want to know what his y value is, I just plug -1 in where the x is into the original equation. So -1 minus 3 and -1 plus 5. So this would be 1/4. Again, you can just plug that whole thing in to your calculator. So essentially 1/4 of -16. We're looking at -4 here as the y value of our vertex. Okay. So if that's the case, I'm going to graph that. -1, -4, that's just going to give me a good idea. We know that it's crossing at 3.75 there, so this guy's headed up this direction. Try to make it as U-shape as possible. We can kind of answer those other questions. So the increasing, decreasing, this looks like it decreases first, and then it increases on the right. So we're going to decrease on the left of -1, and then increase on the right of -1. Our domain, again, is -infinity to infinity. And our range, it looks like the graph never drops below -4. So we're going to go -4 up to infinity. Now, again, I just want you to realize all of those pieces I found algebraically. You can also use the calculator to build your graph first, if that's helpful. So if I wanted to take this function 1/4, x minus 3 and x plus 5, I could come to my calculator, and I'm just going to pull up this one. Those of you that at home, if you want to use Desmos, you could do that as well. I'll show you on that one. But if we have y is equal to, again, we would just put in 1 divided by 4, and we would put in x minus 3, I hope I get this right, x plus 5, I think that's what it was. And you can always graph it and kind of look at that graph and build a graph off of that. Or you could push second graph and then use this table of values and plot some of those points that make sense. So -3, -3, -1, -4, there's our vertex. So you can plot each of those points and it should help you kind of build the graph that you're looking at here. Again, if you're at home and you want to use Desmos, this is just that free online graphing calculator. You just come in here and you do the same thing. You're going to put y is equal to 1/4, and then we would go parenthesis x minus 3, parenthesis, x plus 5. And notice that plots that graph very nicely for you. It even shows you where these intercepts are going to be. If you just highlight them, there's your y-intercept, there's your x-intercept, there's your vertex. It gives you plenty of points to go ahead and plot and graph an accurate shape there. Okay, those are all the forms and all of their key features. So work through that and then use the key to kind of help check to see how you're doing.